Would Google have created the ChatGPT moment? I don't think Google had any idea then. Otherwise, they probably wouldn't have given it away.
People were saying Google missed the AI wave, but I think they've come back super strong. Like the models that they're building, potentially the best model, they may have surpassed OpenAI.
And they have a money printing machine in the back.
That can fuel it.
And they have a data printing machine.
And the talent, right? Like the concentration of talent is surreal. They've caught up on a technological basis. The next big question mark is from a product perspective, can they actually compete?
Listed as one of the co-authors of what has now become one of the most consequential papers in our industry. What is the core unique insight in that paper that propelled so much of this forward?
Efficiency. It was extremely well suited to scaling it up across many GPUs. That was a very important property for the future of machine learning because everyone started scaling up models. And so the models that scaled the best dominated, and that turned out to be the transformer.
Welcome to Grit. I'm Joubin, partner at Kleiner Perkins, a show where we go beyond the highlight reel and explore the personal and professional challenges of building history-making companies. Today on the show, we're joined by Aidan Gomez, co-founder and CEO of Cohere. He is a Google Brain alum and the co-author of the famous paper, Attention is All You Need. Cohere is building an enterprise-first LLM infrastructure and trying to go into the enterprise and regulated sectors like finance and healthcare. Their company is valued at around $6.8 billion, and they are in the eye of all eyes of the AI hurricane. Enjoy the episode. I used to travel a lot.
Mm-hmm.
I have been more busy on the home front here.
Kids?
What's that?
Do you have kids?
Not yet, but just life has gotten busier here. There's a lot of action happening in the Bay Area.
That's very true. Yeah.
Yeah, there's just a lot going on.
Yeah.
I would say, you're kind of in the sales job right now. Like the CEO job at this point of the company is kind of a sales job.
Totally.
I grew up in sales. And so I've been traveling for a long time.
Right. As part of that sales.
Yeah. That's just the gig.
Yeah.
For a while it's cool. And then it becomes not cool.
And people still have this like glorified, like, oh wow, you get to fly every week, as if it's a good thing. And I'm like, it's fucking horrible.
Yeah.
You have like no idea. Like, I wouldn't wish this on my worst enemy.
Yeah. And I think it's actually a good hack for you to bring your wife.
Yeah. Yeah. For as many times as she's willing to.
But then do you feel guilty when you go to
like meetings all day and she's alone?
Yeah. And then like a work dinner?
Well, I just insist that my wife has to come to my.
No way.
Totally. I'm just like, she's on this trip with me. Come, meet my wife. And they're actually stoked about it.
Any meeting that you have?
Any dinner meeting? Yeah. Not like meetings during the day.
Is she in tech?
No.
Okay.
But I mean, by proximity, sort of, right?
Well, by proximity, a lot.
Yeah.
And sorry, just so I can be precise about this, when you travel, you'll be like, all right, sweetheart, I have XYZ trips coming up.
Mm-hmm.
This is the itinerary.
Yeah.
This is where I'm going.
Yeah. Which one? Set of the menu of options.
Which one do you want to go to?
Yeah. Exactly. Yeah.
And then she picks, something from the appetizer, something from the main, something from the dessert.
Yeah.
And then when you go, she comes to the dinners with you. Doesn't go to the meetings all day. And then you come back to the hotel, get ready. She gets ready with you. You guys go to dinner together.
Yeah, exactly.
That's cool. I mean, look, I guess when you're you and the company is, what's the last, you raised it, whatever, 6, 7 billion?
$7 billion.
$7 billion?
List, yeah.
You're like, one of the authors of the paper that started a lot of this craziness at Google. Attention is all you need. I guess there's probably a lot of people that want to sit down with you. And if the trade-off is, hey,
they have to have dinner with Emily.
That seems pretty fair.
I think that's okay. That's actually better. I think they usually prefer talking to her than me.
Yeah.
I mean, she's more interested.
Yeah. There you go. Good. Well, thanks for doing this.
Yeah. Thanks for having me on.
When the paper that you wrote, that you co-wrote, I guess you co-authored it, right?
Mm-hmm.
With whatever, 8 people, 9 people at Google?
There's 8 of us. Yeah.
You were an intern, is that right?
Yeah, I was still an undergrad. Yeah, third year undergrad.
And I'm like, okay, can you just tell me the story? Like, how did that come to be? Because I'm like, okay, did he like write a few words and then like get his name on there? Like, I just have a hard
Pretty much.
time. I just like, I'm just imagining you at, how old were you?
I was 19.
19.
Yeah.
Being listed as one of the co-authors of what has now become maybe one of the most consequential papers in our industry.
Totally, yeah.
Obviously, I don't think you had any idea then. I don't think Google had any idea then. Otherwise, they probably wouldn't have given it away.
Yeah.
Tell me.
Yeah. Well, I mean, would it have been big if Google didn't give it away? Would it have blown up like this, right? If
You're
that had just been a
saying,
secret?
would Google have known would Google have created the ChatGPT moment?
Yeah, exactly. Or would have the academic community created a different architecture under a different name that looked very similar and felt very similar that carried the weight instead. And so maybe Google had its proprietary transformer model, which nobody could use because it was IP and it didn't become very popular. But the rest of the world created something slightly different, which had enough of the same properties to drive all the stuff that we've seen over the past 10 years. I think that's probably more likely. Because at the time, there were the transformer was built off of a set of ideas like, what was it called? ByteNet, WaveNet, whatever it was, like Seek to Seek. There were these series of papers which had these ideas of autoregressive models, which were much more scalable for training. And the ideas were out there in the ether, and we just sort of pulled them together in a particular arrangement. I think if we hadn't have done it, someone else would have within the next 12 to 18 months. So if Google didn't tell anyone about it, kept it secret, I think someone outside would have created something very similar under a different name.
Why do you think that?
Because all those ideas were in the ether.
It was just building towards that.
Yeah, totally. It was necessary. Something like the transformer had to be tried by someone. It's just that, we were the ones that tried it first. And we got enough eyes on it to catalyze this snowball. And once it started rolling, once people started...
This is once you wrote the paper.
Yeah, once we released it, published it at NeurIPS, it got enough eyes and momentum that the community figured the rest out, right? We sort of started the seed, packed a little snowball and then gave it a little nudge down a hill. And then the community just poured in and started implementing all the different frameworks, testing this thing on all the different benchmarks. And the community carried the work. It was less like us at Google pushing this thing forward, showing the world what it could do. It was everybody else taking this little seed and growing it into what the transformer is today.
And in your words, what is the core unique insight in that paper that propelled so much of this forward?
A focus on efficiency. So it was a very simple architecture, very minimal. And it was extremely well suited to scaling it up across many GPUs. At the time we built it, many GPUs was tens of GPUs, right? That was
And what's many GPUs today?
Oh, tens of thousands, maybe hundreds of thousands. In a couple of years, maybe millions. But yeah, so the core insight was, hey, we're going to need to scale this thing up. And for us, that meant instead of training on one GPU, we would like to train on 32. And so let's make sure we build a training framework and an architecture that's compatible with that. It makes that easy, makes it efficient. And then it just so turned out that, that was a very important property for the future of machine learning because everyone started scaling up models. And so the models that scaled the best dominated, and that turned out to be the transformer.
But at the time, obviously, how clearly do you even have the events that have transpired over the last few years fuzzied your memory of what actually happened?
I have a terrible memory. So, I can't even answer that. I don't know.
That's funny.
I have certain, there are just these really core memories from that time period. Because the other thing to remember is that the entire Transformer project happened in, 12 to 16 weeks, about 4 months. And so everything is compressed into this one little period in time in 2017. And yeah, I have moments like the night we submitted to NeurIPS, which was the conference we published the paper at. I slept at the office that night, and a cleaner who was cleaning the offices, I was in this little phone booth sleeping, opened the door and it hit me in the head, and that woke me up. And I remember another moment where I was laying on the couch next to Ashish, Ashish Vaswani, the first author of the paper. And we had submitted the paper, and I was lying next to him, sort of looking up at him. And he's like, dude, this is going to be a big deal. And I was an intern, and this was my first paper that I was submitting to a conference. And so I was like, what do you mean? Aren't all papers like this? Right. And so I always say that I never had any idea what was coming, but Ashish on that night told me this was going to be a big deal. Now, what I think he was saying was we're going to get hundreds of citations on this paper. This is going to be huge.
Right.
And at this point, it's hundreds of thousands.
Yeah.
So I don't think anyone expected the full scale of the impact.
At this point, people are pointing to that paper as the catalyst for a next era of an industrial revolution.
Yeah, which is kind of insane.
Not to over dramatize it, but that's a pretty big deal.
It was a productive 4 months.
No doubt. It's a good thing you slept in the office and cranked through some words. Yeah. From all the things that I have heard, it seems like everybody was caught off guard that these things have been able to scale with more compute and data in the way that they have so far, for as long as they have. And I wonder, is that surprising to you?
It totally, yeah. Around even around the time Cohere got started, it still wasn't clear. There were still papers being written about, theory papers showing that as you scale models, they should actually get worse. There's a period where they get better as you scale them up, and then they start getting worse. And, some of the big names in the field just didn't have this conviction that bigger is better forever. And so it was a very contrarian viewpoint to say that we could just continue scaling these things up from a model perspective, from a data perspective, and we would continue to get sustained gains. I think even when I started Cohere, I don't know if I really believed that. All I knew is there was still some juice to squeeze, and I thought things might taper out, and just the scaling pursuit wouldn't be enough. And I think that's turned out to be true, right? The models, if you believe rumors, GPT-5 is not as big as previous models. It's actually getting small. And they did that because the Orion series, which was much larger, didn't succeed. It didn't make things materially better. And so there's a refocusing, instead of just scaling up models and pre-training and data, to better data, better training methods, new training methods, instead of just pursuing that. So I think we have squeezed a lot out of that pure scaling play.
Yeah.
And it's starting to saturate at this point.
Yeah.
But yeah, people didn't really, have conviction in that at the time, except for OpenAI. And they made that crazy bet. And it turned out to be true for way longer than people thought.
Yeah.
But now we've started to see that sort of taper off.
And so do you think that the GPT-5 model is smaller because internally they just don't think the scaling laws are going to continue to apply in the same way?
I don't know what they think internally. I have no idea. I think that...
do you think we're saturating these?
I do think that for sure on pre-training.
Maybe I'll ask it a more simplistic way. The next set of models from Anthropic and OpenAI, do you if we throw the same amount or double the amount of data and money and GPUs at the problem, yes, well, maybe are we going to get diminished returns? Are we going to get such diminished returns that it doesn't make sense anymore? Like, is it going to be a thing? You have no, like, just, you're guessing, right? So let's just caveat with your guessing. But you're a pretty good person to guess. Like, is it, if we get half the progress, that's still from whatever, 3.5 to 4, that's still pretty amazing. Might still be worth it. I'm curious, like, how you see that.
Yeah, it's an economic question, right? Like, if you look at the level of spending going on to train these models, it is doubling in size or 10xing in size in terms of what you spend to build a model economic. I would say at this stage, we don't have strong evidence that that's the case. The past couple model iterations from the labs that are willing to spend tens of billions of dollars on this, they have largely saturated. People see that. The rate of progress is slowing down considerably, and they're not slowing down on spend and scale. And so, like, purely looking at, one model generation to the next over the past couple cycles, we haven't seen big jumps come through. And for the core businesses, like for the consumer chatbots, I don't think the consumer can feel a material difference. It's not making it so much better for them that they're willing to pay 10 times as much per month to access that model. So we are, in that respect, entering into sort of uneconomic territory. Now, that's the consumer side of things. There's the enterprise side of things. There's the science side of things, right? Like, what is curing cancer worth, right? Like, what is these sort of much higher level scientific breakthrough type pursuits worth, and how much are you willing to pay to unlock that? Maybe there it becomes economic, right? So I think a lot of labs are refocusing around, LLMs for science to drive that sort of innovation forward, under the hope that governments or extremely large entities will be willing to pay pretty much anything to get access to the outputs of those models.
Okay, you're traveling a lot. You're building Cohere, which we should talk about. But, like, in the meantime, how much are you keeping up to speed on, like, okay, you wrote the first paper. Like, how academic are you still these days on the things that are happening?
Dude, I'm non-technical. I'm cooked. Like,
you think you're done?
Yeah, I think I'm more annoying to the modeling team at Cohere than I am helpful. And I'm being self-deprecating, but, like, I keep up with the papers that I find extremely interesting. I used to read just, out of the fire hose, right? Like, anything that was coming out, I would consume it religiously. At this point, I read a paper, like, I don't know, once a quarter type thing, twice a quarter. And it's only if it's super interesting. There's people around me. There's, like, fantastic researchers on the Cohere team who will, like, surface things to me, like, Aidan, you need to see this.
So I have really are turning into a sales guy. Jeez,
dude, it fucking sucks. It sucks. But no, I mean, it's a privilege as well, right?
Yeah.
Like we were talking about, I get to go to really cool places. I get to meet really cool people, and be involved in a different side of the field, right? Like, I used to be a researcher, but now I get to, help set policy, help actually deploy the technology into the global economy. Get to see that sort of at the front line in a way that when I was in Oxford, or, when I was in Mountain View or Toronto, doing research, I was so far from that shit. I was so far from anyone actually using the stuff that I was building. So no, it's a different job. It's a different job. I do miss research though. And I am annoying to the Cohere modeling team. I always have ideas. We should be trying this. We should.
What kind of ideas? Like technical breakthrough ideas? Like things that efficiency ideas.
Yeah, stuff like that. Like I don't know, like multi-hop prediction, lots of stuff about like, can we train models low rank to get much better, efficiency out of these things and like get more out of the training compute? Can we make pre-training more efficient? Data curriculums, right? Like first train on the easy stuff and then train on harder stuff, train on the noisier stuff first and then the cleaner stuff. I have so many ideas on like how to make this shit more efficient just because that's where I came from.
Yeah.
And then of course I have like, I guess the one place that I still do contribute are sort of the meta or like the product level modeling questions. It's like one of those is, how like reasoning models, I guess like this time last year came out. And since then, they've just unlocked a category of problem that previously you could not solve with LLMs, and now you can.
Like what?
Like, complicated math, a lot of coding debugging needs reasoning. You need to understand why that first attempt failed, fix that. Tool use inside of the enterprise, like using all these enterprise systems, something might fail. One attempt at accomplishing something might fail, and you need to reroute and figure out how to solve that. And that requires reasoning to do that. And reasoning was so obvious. Like, it surprised people who I think were one step removed from language models. But good God, like the premise of a language model where you have an input stream, which is like a series of words, that input space is everything. Like those words could be any question. It's something as simple as like, what's 1 + 1, which should be quite easy to answer, but also like a question, how do we solve this theorem, like this millennium problem, or how to, what is the cure to cancer, right? Like the problem you present the model with varies in complexity massively. And yet language models pre-reasoning would spend the same amount of compute answering those two massively different levels of complexity. Whereas with humans, like we spend different, some problems we work on for decades and some problems we can answer immediately. So reasoning gave us that variability of compute or effort to solve varying complexities of problem. But there are other very obviously missing capabilities in these models that humans have. So one of those is learning from experience. Like when Cohere is like my first company. When I founded Cohere, I had zero experience in founding a company. And so I f***ed up everything, like every mistake you could make building a company. I promise you I've done it. But the good thing about being a human is you learn from that experience. You get a little bit better that first fuck up. Hopefully you don't make it more than once. And you grow over time. You become massively more competent. LLMs, if I spend a month working with an LLM, like as a sort of colleague with me, and then I press new chat, it's reset to that same LLM that I was speaking to at the beginning of that month. And so it's like, that's an obvious trait of intelligence that we're missing. So I think that will be the next thing that comes out. And that's the type of thing that I push the team on, is like, we're missing this.
Yeah.
Think of what this unlocks at the product level.
Yeah.
We need it.
Is that like a memory problem? Like, is that like a recall of memory problem?
It is. Yeah, for sure. For sure. Memory is a huge component of that. It's also learning skills. So distilling out of memories, distilling out of experience, abstractable skills that you can apply elsewhere.
And I guess if you believe that that's like the next shoe to drop in the space that you think is as obvious as reasoning was, whatever, 12 or 18 months ago, then you really don't even need we could stop at the models today. Like, you don't need any more advancement to be able to improve memory and recall and some of the things that you're describing, right?
So are you saying we don't need a new architecture?
I'm saying, like, if we stopped at GPT-5, right? Like, we don't need GPT-6 in order to improve this specific problem that you're describing?
Well, I think GPT-6 is the solution to the next major update to language models will be this capability.
You think so?
Absolutely.
And what will that mean for the consumer and for the enterprise?
It means it will get smarter over time without you having to go train a new model. It'll learn more about you. It'll learn more about, for Cohere, it'll learn more about the enterprises that we work with. Like initially the model shows up and it's like an intern out of school. It has like a bunch of general experience. Universities and schools are fantastic at giving generic knowledge about a field. But when that intern shows up, they completely lack the specific knowledge of your business, your product, your customers, etc. But over time, that intern becomes more experienced, gets a full-time offer, has been there for a few years, and they're dramatically more productive and effective for you. And so just the fact that they've been sitting there running, seeing your business, they become more valuable to you. That's the product unlock, is that with more time and more use, this asset becomes increasingly high ROI to you.
And is the argument that, I think OpenAI planted their flag in the ground that around this time next year, maybe, their goal is to have an AI researcher. And maybe if the path is very obvious to GPT-6 being this key unlock where the system self-learns much more efficaciously than it used to, right? Similar to how a human does, then does it get to the path where it can also start to train itself? Does it start to get to the path where if it starts to learn from its own mistakes, like even today or yesterday, I think I saw something in a paper about signs of self-awareness in Claude's model. But if it starts to become self-aware, whatever. You disagree with you think that's BS?
Yeah, I think it's BS.
Why?
I don't know. The effective altruist crowd loves to personify these things, and
you think it's totally stupid.
Yeah, I think. Yeah, yes, I do.
I want to revisit that in a second, but is that the path to the model doing a lot of its heavy lifting on its own?
Yeah, I mean, to self-improvement. Already, there's a lot of self-improvement. Actually, just to be clear, synthetic data. People did not believe in synthetic data a couple years ago. They were saying you can't learn it. It's like an Ouroboros. It's like, human centipede of data. It's like if the model is producing its own data, it can't make itself smarter, right? There's some sort of limit there or degradation that's going to take place. But now across every single lab, the majority of the data is synthetic. It's just, there's so much to be won by having these models reformat their own data in a way that lets them learn more effectively, that filters for better data, structures things in a better way. Already these models are sort of teaching themselves or helping themselves learn. The AI scientist thing from OpenAI, I don't know. Let's see. There's been a lot of this meta learning stuff where you get models to tweak hyperparams and do search. And it's all sort of been a very expensive waste of time.
You seem a little annoyed by the model companies. Let me just put it that way. Maybe
Cohere is a model company.
Well, okay. You seem a little annoyed by the bluster of what a lot of these labs are saying. Is that a fair characterization?
That's a fair characterization. I think the whole AGI, ASI, doomsday stuff, the goalposts keep moving, right? It was we can't release, GPT-3 because it literally might kill the world. That was the sort of ethos that was out there. This is so dangerous. You need to lock this down. Let's bomb data centers of our adversaries so that they can't build models. And also all of the, roll back 2 years, you have folks, I won't name names, but you have folks who are saying, there is going to be just an exponential takeoff of model capability because having the smartest model means it's easier to build the next smartest model. and it'll just run away. And the first person to get there takes the whole cake. And in reality, look at what has happened over the past couple of years. We have like 5 to 7 models that have all converged to the same fixed point. They're all like interchangeable. There's barely any different. Like, not only has like someone else caught up with a lot of resources, like 7 have. And so there were all these extraordinary claims and sort of posturing made, which we've just seen over time repeatedly prove to be demonstrably false. And it feels like, that bravado, that sort of posturing did a real disservice to the world.
Why?
And I think it was posturing to like scare others off from trying.
Right.
You'll never be able to catch up.
Right.
We're already ahead. There's no way that you can do it.
Right. Or saying how much money or energy you need in order to.
Yeah, exactly. Or going to the government and saying, we have to control this. No one should be allowed except for me and my buddies to train something.
You think it's pulling the ladder up behind you?
Totally. And I think that was a highly effective strategy. I think it scared off a lot of people. I think it scared investors. It scared this, that, and the other. It scared regulators, policy people. It was a hyper effective strategy of pulling up the ladder and disincentivizing people to participate and try and play. And it was extremely intellectually dishonest, which I think is what hurts the most, because these were claims about the technology, and these were very unreasonable extrapolations. And so if you've heard them for half a decade espousing this, pushing this with so much conviction, so much confidence, there is a certain, I don't like that. I'm kind of done with that phase of like, the world should be afraid of this technology. This technology is going to destroy the world. I think the technology could save the world, right? Like, I think this technology is so high leverage across so many different fields. We shouldn't be scared of it. We should be running towards it. We should be deploying it as quickly as we can. And I think the world has broadly accepted that now. But a year ago, 2 years ago, it was a very different story.
Yeah, the thing that we're hearing now is, oh, well, just wait until it gets into robots. Like, that's when things are going to be really scary, And so it seems like the pressure points of fear just shift into other areas, right?
Yeah, fear is motivating. Like, if you can catalyze fear in a direction that's productive to you, it's a super effective strategy. I think it's like a really ugly strategy. I don't like it. But it's proven quite effective in AI.
Can you give the 30 seconds on Cohere?
Yeah, sure. So we're a modeling company. We build models. We also build the framework and platform around the models to deploy them into businesses. So if you think about what a model needs to be productive inside of a company, it needs the same level of access that you grant, trust and access that you grant to your humans inside the organization. So it needs to be able to use your sales software, HR software, marketing software, your email, your calendar, your supply chain software, everything. And it needs to be able to use it in the same way a human uses it. And so that's what we built. That's our North platform. It integrates into, we focus mostly on what I would describe as critical industries, public sector, energy, financial services, healthcare, telco, anywhere that data is a national security concern. And these are sort of the foundations of a country's economy. Cohere does extremely well, principally because our deployment model is different than the other guys, where instead of deploying only on cloud, yes, we can deploy on all clouds, but we can also go on-prem. And so for extremely secure settings where maybe you even want to go air-gapped, our models run just fine. And so they're designed for these very private, strict environments from scratch. We set a constraint saying, the model we build, we're not just going to build the biggest model, because the enterprise market cannot consume the biggest model. It's just, they're not willing to spend that much. They don't have, hundreds of millions of consumers that are going to be using this thing. They need something that is right sized to the infrastructure that they do have. So we set a constraint saying within 2 GPUs, we are going to squeeze the most intelligence out of those 2 GPUs that we can. But that's the cap. If the model fits on 3 GPUs, we're not building that model. It's 2 GPUs. That's our footprint. That's what we're going with. And so that's what we've been focused on for the past 6 years, is deploying that. And, we've scaled globally. We have offices I'm from Toronto. So, Nick, Ivan, and I are from Toronto. That's the HQ. We have an office here in SF, New York, Montreal, Paris, London, Seoul, opening up in Riyadh soon. So yeah, and the customer base is global. It sort of mirrors that, right? Like Saudi Telecom, Fujitsu, LG, the British government, Canadian telcos, American banks. And so we've scaled quite rapidly over the past couple of years. Let's do like DeepSeek, right? Like
Sure.
DeepSeek was like 700 billion parameters, and probably required something like 8 to 16 GPUs. The behemoth model from Meta, I think, was like 1 trillion parameters. Would have required dramatically more than that. Although they never released it, so nobody knows. Rumors about like GPT-4o and these models, it's like tens of GPUs, like 32 maybe.
Like, I'm curious what your perspective is on, like, I spent a bunch of time with big enterprises. It's like, was it a CIO thing for the last couple of weeks? I've been more like flipping 100 CIOs.
Those are fun. Always fun.
Yeah, you should come hang out with us. And, like, we're still in this period of time where the board is telling the CEO, who's telling the executive team, we need AI.
Yeah.
Just like, whatever that means, we need it. That's like, our kids use ChatGPT and I use it. It's amazing. And therefore, like, boom.
Mm-hmm.
And I think it seems to me that music will not go on forever. And what I mean by that is, like, I do think that they will probably skinny down the aperture rather than letting 1,000 flowers bloom to maybe a few things that they really invest in.
Mm-hmm.
And so I think that's like one half of it that I want your perspective on, is like, this voracious of an appetite is unsustainable. They need to digest the technology. And the second is, if in tandem, the models slow down, which they already have, to your point,
Mm-hmm.
like, if those two things converge in a moment in time, I wonder what you think that means. First, do you agree with those two premises? And then if those two things happen at the same time or around the same time, what does that mean?
The appetite being less voracious, I disagree with, but probably not in the way that you think. So, like, I agree with you that the aperture is going to close. There were all these POCs. They were trying everything. It was all like, let's try out 30 different use cases. But I would describe that as actually very low appetite. You're doing a bunch of like test things with like 5 people. And yes, there's 30 of them, but like 30 times 5 isn't that many people. What's happening now is they have narrowed, but now they're blasting this across the entire company. And so it's being deployed across tens of thousands of employees, hundreds of thousands of employees inside of these organizations. The scaling in terms of deployment is massive. So they've gotten conviction on the places where they have a bet that this is going to drive ROI for them. And now they're actually going into production with it. That shift is what we've seen over the past year. The year before, it was a lot of these POCs. It was a lot of like, my board is like, going to fire me if I don't figure out some sort of strategy around AI. And so I'm going to like spin up tons of POCs and like try this, try that, see what works. That period, a lot of those POCs failed. I would say for like Cohere's customers, we did quite well. Like we helped steer their bets. We didn't let them spend time on POCs that weren't going to succeed from the outset. But obviously, we're a 500-person company. There are much larger GSIs and that type of thing, which have 1 million employees who were doing a lot of these bad ideas from the outset. But now companies have kind of seen the space and they've gained a familiarity with the technology, where it works, where it doesn't. And they're making bets and scaling them across the business. And that process, I think, is the most exciting one, because this is where we actually start to see ROI and impact. You can't have ROI on a business in front of like a test group of 30 users or 100 or even 1,000, right? You need to roll out broadly. So that's the phase that we're in.
Okay, that's fair. And when you go into one of these customers, are you like Palantir style pitching the platform and then helping them come up with areas that they can apply this amazing technology within their business?
Yeah. So we have, you can kind of describe it as like two models of going to market. One is just, we have our models, right? Which is like our re-rank model, our embed model, our command model, our set of models that are accessible via an API that you can get access to. And that's completely self-serve. And on the other side, there are these strategic enterprise engagements where we say, we have these models, we have the tech stack around it to actually make them productive and put them to work. Let's work together to execute your AI agent roadmap together. And so at that point, we do deploy FDEs. We bring expertise to the table. We help them train their own people on how to do this work, how to set it up. And then eventually we can sort of let them run and do their thing on top of our platform.
Mm-hmm. That makes sense. How much money have you raised?
We've raised I think like 6 or 7 billion.
For what? Like, where does that money go?
For compute, for people, just like scaling up the go-to-market, right? Like we have a very global presence.
Okay, but a lot of it's compute. 1.7 billion for people and go-to-market is a lot.
Yeah. Well, it's been 6 years, and this is like very expensive talent. That's another thing that's important to remember. But yeah, a huge chunk of the money.
Like the researchers were saying.
Yeah. A huge chunk of the money goes to compute, data, and people.
Yeah.
I would say that's like 80%.
Yeah, okay. That makes sense.
Mm-hmm.
On the people side, like these researchers, you must be caught in the same, like, I love the TBPN trading cards where the researcher traded from so like Anthropic. It's so fun.
Dude, those guys are so good.
Yeah, they're really good.
So funny.
Yeah, they're really good. You must be caught up in the same game, right? Have to be. Like, there's only what do you think? What do you think the N is of researchers that are worthy of S tier that all the labs want?
S tier? Oh man. I don't know, 150 people.
That's it.
200, yeah.
That's it.
Probably, yeah.
And are all of you guys going after those? And I assume they're well known.
Yeah, everybody knows who they are. Yeah.
Like everybody has a master list.
Yeah. You track where they are.
You do,
try
right?
to stay close to them. How are they feeling? Was their manager nice to them? Blah blah blah. No, we don't do the sort of like intelligence type work, but definitely you know who they are, and
you're competing for them,
and you're competing for them. But the list is growing. Maybe my 200 number is actually out of date, and it's like 4x that, because way more people are just getting hands-on experience doing the work over the past few years. But it's still a small and very competitive crowd. Some of the numbers, like the meta stuff, right, of like paying like $100 million a year, that type of thing. Cohere will just not compete with that. Like you can't, right? And it also, people who are that mercenary and who are just there for dollars, that category of talent is very loose. Like, yeah, they'll be with you for a little bit, but then they'll go somewhere else. And so we don't we're not actually that. I'm not that attracted to that sort of talent. Like I want talent that is here for a mission, purpose driven, wants to be at Cohere, and will fight to build this generational organization with me. So we don't try to go after mercenary talent. And the other thing is like upside, right? Like Meta is not going to 10x, but the project at Cohere is we have to 10x at least, right? Like that is why we're all here. And so folks who are focused on building instead of just extracting, that's the type of person that we want at Cohere.
Mm-hmm. Crazy times, eh?
Yeah, it is crazy times for sure. Yeah. On the talent side, I think there's never been a better time to get into machine learning.
Do you don't be falsely modest. Would you have considered yourself S tier coming out of Google?
Yeah, I mean, I definitely had a set of experiences that there were probably tens of people on the planet who had worked on something like that. When we started Cohere, there were tens of people who had trained language models on the planet. Maybe 20 people, 15 to 30 people. That was it.
And is it fair to say that those tens are all either the heads of the large language model companies or started their own?
No.
Where are they?
No, they're all over the place. Like they're all in leadership positions at this stage. But there's very few that are the heads of startups and companies.
Yeah, it's a funny in Silicon Valley for a long time we've been seeing engineers that go build companies, but in many ways like a researcher is an even more extreme version of a type of engineer. If that makes generally more shy, more interested in I just think about the whiplash of your metamorphosis of having to turn into from Oxford to research to Google researcher to now flying around the world on stage.
Yeah.
This has not got to be the thing that gives you energy.
It's not my nature. No, it's very much a learned behavior, which I think that's not a good thing, right? That's not helpful. It means I have to put a lot of effort into faking extroversion.
Yeah, it feels like drudgery.
Yeah, you get used to it though. It's less tiring the more practice you have. And I've had half a decade of practice doing this. And so I think I've gotten, materially better at it. But you're completely right to say it's not my nature to want to be on stage and, I'm not a public speaker. That's not what I enjoy. I like hanging out with small groups and working on really interesting problems. I love that shit. But you learn and you grow. And I think I've gotten good enough at it to be productive.
Yeah, but do you think you can learn to enjoy it?
I do enjoy. I'm enjoying this conversation.
Yeah.
Right. I think it's totally something you can learn to see the nice parts in, because most of that disinterest in getting up on stage is just shyness, right? It's just
totally.
And the shyness never goes away, but it gets easier to the point where you can actually enjoy the process. You get to meet cool people, you get to talk about interesting things, and you get a platform to give your opinion and your view of things to the world. And so I appreciate all those things. Those are really nice. Even if I don't like standing up on a stage in front of, 1,000 people, that process is uncomfortable to me. I can see past that.
Yeah, I think that's well said. Can I revisit the earlier part of our conversation about if Google had not given away the paper and the technology, how the world could be different? Do you You still probably have a bunch of friends there.
Yes. A lot of them left.
Did
A couple
they?
of them have come back. Yeah, I have a bunch of friends there.
Are you impressed by what they're doing?
Oh, totally. Yeah. No,
Like by what Gemini's doing?
totally. Yeah. No, I think Demis like saved Google.
You think so?
Yeah.
Demis is the CEO of DeepMind?
Yeah. It got absorbed into Google.
Yes. And now does he run Gemini technically?
Yeah. Certainly. Yeah. No, I think he did a fantastic job. I'm really proud of it. Like Google sort of raised me, right? Like I was still a student in school. Once I left school and went to Oxford to do my PhD, I was still working at Google. And it always, I think I'm like on the record in various interviews saying, I really hope Google gets its act together, because people were saying Google missed the AI wave. There was all this sort of like, they sort of this one up. But I think they've come back super strong. Like the models that they're building,
they seem great.
They're potentially the best model right now, actually. They may have surpassed OpenAI. We'll see with Gemini 3, but totally plausible to me that they are actually the best model that exists today.
And they have a money printing machine in the back
that can fuel it. Yeah. Mm-hmm.
And they have a data printing machine that continues to absorb a bunch of data.
Totally. They have all the talent, right? Like Google Brain and DeepMind, they were like Bell Labs, right? Like the concentration of talent, surreal. Just the level of expertise in AI that they were able to amass. They had everything they needed to. So it's really no surprise that they've caught up on a technological basis. The next big question mark is from a product perspective. Can they actually compete? Because I think Gemini has very low market share, growing, but very low still.
Mm-hmm. And where do they want to compete?
Well, they're a consumer company through and through. Like that is really what Google is. With cloud, they try to do some enterprise stuff. But if Google doesn't win if Google doesn't win consumer, it'll be bad. So that is the fight they have to win.
Why will it be bad?
That's the money printing machine, right? Like
bad for Google, you're saying?
Yes, that would be bad for Google. Really bad for Google if they can't win the consumer game.
Yeah. How'd you get into all this in the first place?
AI?
Yeah.
I grew up in Canada. I was born in Toronto, but like my parents moved out of the city before I was 1. And my dad built a log home inside of 150 acres of Canadian wilderness.
That's where you grew up?
That's where I grew up, yeah.
In a log home?
In a log house that my dad built in the
wilderness
forest. Yeah, and like,
sick.
In March, the sap starts running. So we would tap the maple trees. We had a little sugar shack.
Wow. That's really Canadian
upbringing.
That's really
but both my parents weren't born in Canada. They were both immigrants. Right?
Yeah.
And my dad's he was born in Spain. My mom was British. So I had these two immigrants who gave me like the world's most Canadian upbringing. And yeah, I like early on, I just loved computers. Technology, I was just obsessed with it. I just wanted to hack my Wii. I would like unscrew my Wii and like you could buy these chips on the internet from China or some shit where you like attach the chip on top of the Wii chip and it gives you a bunch of games for free, that type of thing. Jailbreaking my PlayStation, all this sort of stuff is like what I love to do. And I just thought when I went to school
being
U of T, University of Toronto, I just thought artificial intelligence, it was the most interesting unsolved question.
What year was this?
2013, 2014.
Okay.
And when you go to U of T, like this is where, Ilya came from there, Jeff Hinton's there, like just tons of incredible people who have defined the entire field. You sort of get raised into AI. You have access to professors and to PhD students and postdocs who they've been thinking more about this than anyone else on the planet. So Toronto had like this concentration of just AI knowledge. And Toronto was really the place it got built. And so I, for like some reason, chose U of T because it was my local university and ended up steeped in and raised into AI. Yeah, I think it's the most beautiful unanswered question. We know so much about physics, not everything, but we know so much. We can explain things, we can predict things down to like, incredible precision. But when it comes to what is intelligence, like how did we get so smart? Like what properties enabled us to be so qualitatively different than every other animal that came before us? It's the one thing that separates us from the rest of all of these different species. It's our intelligence. And so it's this like great mystery. And like humans have come up with so many different explanations for how that happened, why it happened, what it means that it happened. And I just thought exploring that was like the most exciting, beautiful thing to explore.
Mm. It is crazy to think that the people that you had named, Ilya, Jeff Hinton,
so many more, Jan LeCun, like all these,
all from U of T.
They all went through the U of T.
That's crazy.
Yeah, no, it's insane. It's insane.
Do you keep up with those guys?
Jeff, definitely. Like my co-founder, Nick, he plays chess with Jeff like every Monday. Like, he's still in Toronto. He's right there. Ilya, I knew him when I was a student in U of T. And, at one point we were talking about me joining OpenAI, at some stage. And so I had a lot of conversations with Ilya about that.
Early days, I imagine.
Yeah. This was like around the same time as the Transformer, probably like 8 years ago.
Why didn't you do it?
Why didn't I? I wanted to get a PhD. I wanted to like go continue to learn. And so I went off to Oxford and I decided to do that. And I'm very grateful that I did. It would have been great at OpenAI as well. I think I'm in a much more interesting place because I did that. But yeah, the question of like doing a PhD versus going into industry now is very interesting. Like the most sort of frontier work you can do tends to be in industry. There's exceptions and you can still do very productive work in academia. But I think a lot of research is actually happening outside of academia, which is not nice in many ways, right? Because a lot of that doesn't get spoken about, written up, shared anymore in the way that it used to.
And so if you were in that position again today, you think you'd make the same decision?
Yeah, 100%. Yeah. No, like 100%.
That's got to have been tough though, like seeing had GPT-3 come out yet when Ilya was trying to bring you over to OpenAI?
I don't know. I don't think so. No. Definitely not, because GPT-3 came out after I started Cohere.
Okay. Dang. It's pretty crazy. Because you didn't know. Nobody knew. Like it hadn't really
happened yet.
Hadn't happened yet. I mean, I guess maybe you knew.
You could see it happening. You could see it. I still remember like the first output of a transformer-based language model that I saw. Was an email from my manager, Lukash. And he was like, Aidan, check this out. And it was he had generated a Wikipedia page and he had like prompted it with title, the transformer. And then he just let the model write. And it was like a Japanese punk rock band that like, I still have the email on my phone actually. The whole story of this Japanese punk rock band. And then at the very end, he wrote, I just wrote the transformer. The machine wrote the rest. And now that's like, even when I say it, it's not surprising. It's like, obviously this thing can dream up a transformer Wikipedia page. But in that moment, computers could not write in a fluent way at all. it went from like computers were these dumb things that just bumbled and like, could barely even string a sentence together properly to holy fuck, a human could have written them like all at once. And it was a huge wake up call.
So crazy. It does seem to me that there is a giant opportunity in front of us on the enterprise side. I completely agree with you. I agree with what you're doing business wise. Like, it makes sense to me. Let's assume that the models never get a single iota better.
Mm-hmm.
Just using what we have today in the enterprise, if you go talk to people, you're like, oh, we got a lot of work to do.
Totally. It's still so early for the enterprise. Like we're still doing the super foundational, like summarize this email for me. Summarize these meeting notes for me. It's so basic, low level. I just think there's so much to be done. The models are not a part of our economy yet. They're not. Like they're basically still in test phase or doing the lowest value type of work. Increasingly, they're going to start to do much larger portions of what people do today. In particular, like white collar workers. I think that is a very supply side constrained job market. It's why they're called white collar workers. You have to pay them a lot because there's not a lot of these people for the world. And so there's tons of demand for these people, but there's not enough of those people to do the work the world needs. And it turns out that these models are best at the types of things those people do. It's not, factory line workers doing work. That's not the place that AI is going to have the first impact. It's actually the most constrained, rare skill sets that models are going to be able to augment and leverage.
That's why coding has been such a home run so far.
Exactly. It's a perfect example.
That's why legal has been a home run so far.
Mm-hmm. Yeah. Finance will come, many other fields will.
Isn't that the whole point of this? Like, we're eating a different part of the market where, like, it's not seats and licenses. It's being able to actually augment people, like actually do the jobs of people, in many ways. And that's so much more transformative.
Yeah, completely.
How do you think this is gonna, what else do you think is obvious that you think most people don't in the coming five to, let's just say 5 to 10 year time horizon?
That other people don't think is obvious. I mean, the obvious thing is that this technology is going to percolate into the economy. We're going to start to see some interesting effects in terms of like company productivity. I'm interested and, modestly concerned about labor market impacts. We're going to start to see products being built that fundamentally couldn't have been built before, or companies being built at a level of efficiency that would have been completely impossible, like a team of 1,000 doing what a team of hundreds of thousands presently do. I hope that in the next 5 years, we will see across the developed economies resumed growth and resumed productivity. There's been a lot of stagnation, not here in the States, but I'm Canadian and British, in Canada, in the UK, in Europe, in many parts of Asia. GDP per capita is flat over the past 10, 15 years or declining.
They're really getting in their own way, aren't they?
Oh, well, yeah, they're big time. But even in Canada, there's not that much. Like, Canada doesn't have like EU style regulations, but we have had a really hard go of it.
Yeah.
And that's bad. Economies slowing their growth is very dangerous. Like, over the past century, everyone has gotten richer. Like, access to healthcare, education, everything. Like, the world has just gotten so much richer and the pie has been growing. And so everyone's feeling this. Like, you don't need to fight, like, we don't want war. We're all getting richer. Like, we can all just be friends. We can all we don't need to think in terms of zero sum. But when the pie stops growing, if you want your slice of the pie to be worth more, you have to take it from someone else. And so you start to see xenophobia, right? Like you blame immigrants for the fact that you're not getting richer because they're taking your part of the pie. You start to see, territorial conflicts. Again, you want to expand access to resources and you need to take it from someone else to get it. So a lot of these regressions from like the steady march towards progress, I think come from an economic basis of lack of growth. And my hope is that by diffusing this technology into the economy, we can resume an era of growth, maybe for another half century.
Yeah.
And continue that march steadily to, away from authoritarianism, away from kings, towards liberal democracies.
I was giving this take I was sitting for dinner with the CIO of Deutsche Bank, and I was saying, like, tell me what you think of this take, because you're a very international man these days. You're also from not the States. That like in Europe, like in Germany, which is obviously where he's from, it's almost like one of the best things about Europe is the preservation of its culture. And maybe one of the things that's getting in Europe's way is this anti-technology sentiment, maybe rooted in this idea of preserving culture. And maybe like we have overridden our operating systems to believe that somehow this technology is in one way or another taking away from the culture.
Yeah, I would say it's protectionism that's holding them back for sure.
Yeah.
I think it's this orientation of like their role. The EU has sort of decided that its role is to be the police of other people's other countries' tech companies. That is like seemingly the one hammer they've got is we are just going to regulate. Like we're going to control other people's tech companies. Whereas the framing should have always been, we need to build our own tech companies.
Totally.
Like that.
Totally.
If that was
what a weird way to exert influence.
Exactly. Yeah. Saying that you're going to be like the cop of these companies. And you can see it in like just they hold up the USB-C thing. I think it's great that, the USB, like, look at what we've done. We've managed to like force companies to adopt this. I don't give a fuck about a plug. Please build like a competitive phone, like
right,
go build
right.
a fucking hardware. Go build, a good software company. Like stop. Just it. Yeah. It's like, if you can't do police, but they can do, like, they have incredible universities. They have incredible pools of capital that still exist and are right there. They are completely, they have been. I think most Europeans would agree with me on this. And I want to restate, I'm British and Spanish. I hold both passports. I care deeply. My wife studies in Barcelona. Like, I live in London. I care deeply about Europe. The Europeans need to organize themselves to build the next generation of great companies. That will be the only way to strengthen Europe. It will not be protecting, themselves from someone else's company. It will be by building their own.
Yeah.
The moment that Europe understands that, progress will start to get made.
This was fascinating, and I appreciate you. Really fun.
Yeah, no, this was really great. I really enjoyed it. Really good questions.
Thanks, man. Let's hang sometime and
come to London. Come see me. I'm in Soho.
I'll see you in London.
Yeah, let's do it.
I'd love to. Go see your office, maybe?
Yeah, it's right there in Soho as well. Like a 90-second walk from my house.
Grab some Indian food?
Yeah. There's lots of that. It's very good.
Or whatever food. You don't seem to be a fan of Indian food. We grab whatever food.
You know what? Everyone said that London has like the best Indian food, but not in my experience.
Okay. Well, then I'll let you
Toronto has the best.
I'll let you pick.
Yeah.
Let's do it.
Let's do it.
All right. How are you there? Like half the year?
I'm there I would say like 1 week of every month.
Okay.
Yeah.
All right. Well, I'll ping you
Yeah.
next time I'm out there, and let's see if
Do it.
the ships can.
Yeah, that'd be great. Let's swap numbers.
Yeah. Okay. Sounds good. Are you hiring?
Yes.
What
Always.
are you hiring for?
I'm hiring for everything. Like, you're talking at the exec level?
Yeah. Like, is there any roles you want to shout out?
Oh, no, that's okay. I mean,
like research? I don't know.
Yeah, I guess like ML researchers should message me on Twitter. And
if you're like one of the 200 to maybe 800.
Yeah. Yeah. No, I mean, Cohere's growing in every function. Like we have to triple our sales team. We have to, like the delivery side, FDEs, that type of thing. We have to grow that massively. We are currently extremely resource constrained on the people front.
Okay.
We're way too small.
Well, thank you. Thank you for doing this. We're getting kicked out. Last question. When you hear the word grit, what do you think of? I gotta ask everybody.
You hear the word grit. What do you think of? Dirt? Toughness.
Dirt.
Yeah. I think the ability to withstand pain. That's what I think of.
I can't wait to see what you do. I'm excited for you, man.
Thanks, dude.
Yeah.
That means a lot.
Yeah, I'm really excited for you. That's it for now. If you liked the episode, please leave us a review or go back into the archives where we've done more than 200 episodes with some fantastic folks. This podcast is a Kleiner Perkins production, and I'm Joubin. Thanks for listening.